Hello friend, welcome to this video. In this video we're going to continue looking at basic control structures that you'll need in order to develop application programs for this class. So in the previous previous videos, we looked at the decision control structure. So in this video, the next video, we're going to be looking at what are known as repetition control structures. At least our textbook calls that. They're more commonly called just looping control structures. Okay, so with that, let's go ahead and get started. Okay, so a repetition structure or a loop basically causes a statement or a set of statements, which is a code block. So anytime we say a set of statements, we mean a block of code in a programming language. So a repetition structure causes that block of code to execute repeatedly. Right, so there's many occasions where we need to have a loop in our code. So we often have to write code that performs the same task multiple times. All right, so you could get the same effect by duplicating the code that you need to have repeated multiple times, but there's many disadvantages to that, and often that's impossible to actually do it that way. Right, so some of the disadvantages: it's going to make your program larger, it's time consuming. If you have duplications of things, you're violating what's known as the dry principle, the don't repeat yourself. Okay, so when you have repetitions of things of the same kind of logic, if you need to make a change or correct something, you're going to have to find all the places it's repeated and correct it in many places. So that can often be a source of bugs. Okay. So I will put that link for the site, the Laws of Software Engineering. It might be useful for you to refer to the site. In this course, we will be touching on some of the basics of software engineering. That's what application programming is about, right? So one of the most basic ones, is this idea of the don't repeat yourself principle. Okay, so that's the basic idea, is that every piece of knowledge in a written program should have one single unambiguous authoritative place where it's represented and defined in your program. Okay, so as a kind of a concrete example, this is code from a textbook. I didn't put this in our repository, but this is an example of what we mean by repeating the code. So if I need to calculate the sales commission for a set of salespeople for like my organization, I could just copy this code multiple times. So I could get the amount of sales and the commission rate and calculate that and display it for my first salesperson, and then just copy that however many times that I need, right? So unless I know exactly how many salespeople I have, so if I know that I have 10 salespeople, I could copy that 10 times. And that would work, right? I could copy those 6 or 8 lines 10 times. But of course, it very quickly becomes impractical when you have more than 5 or 10 salespeople, right? And it becomes impossible to use that approach if I don't know how many salespeople are in my organization when I run this program, right? So that might be a variable. So I might need to read in or ask, okay, how many salespeople do you have that we're going to be entering in, calculating the information for? So instead of copying and pasting your code, we want to use a loop, a repetition structure. Okay, so we can have the computer repeat a block of code as necessary, as many times as necessary. Right. So there's going to be 2 types of loops that we'll talk about in this video: condition control loops that just keep going as long as some condition is true, and they stop once the condition becomes false. That's what we mean by condition control loop. Or a count controlled loop, where there's a specific number of times or specific number of things we need to perform an action on, and we're going to do it that set number of times. So in Python, there's 2 basic looping structures. The while loop is what you should use if you have a condition controlled loop. Okay, so a while loop basically keeps doing the statements in the block here. So over here is the syntax for our while loop. So again, this has a Boolean condition like our decision structures we talked about in previous videos. So we're going to be testing if something is true or not. So as long as this is true, we will execute these statements, and then we'll come back up and test it again, right? So that's the loop part. So if the condition is true, we execute statement, 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 then we go back up and test the statement, the condition again, right? So there's two parts for a while loop: the condition that's tested with the while keyword, and don't forget the colon, and then the block of code, the one or more statements that are executed if that condition is true. So as a flowchart, again, we would use that diamond in a flowchart to indicate that we're testing a condition. So the loop comes in is that, if it's true, we're executing one or more statements, and then we go back up and test the condition again, right? So as a little bit of an aside, the while loop in Python is the condition is tested before the loop is entered. So if the condition is false, the loop will never be entered, and you should use that and keep that in mind, right? So that's useful. So sometimes you don't want these statements to be executed any times, to be executed 0 times, in which case the condition should be false, so that we just skip over it as if it was a if statement where the condition was false. And we just skip over executing the statements in the if statement. Okay, so let's look at an example of a while loop that does the calculation of the sales commission. So here's the flowchart of how that might work. So basically, for a condition control loop, in order for the loop to stop executing, something has to happen in one of these statements to make that condition false. Okay, so that condition should initially be true, but something should be being assigned or changed in these statements that will eventually make that condition false. All right. So some terminology. So an iteration, I'll often call this an iteration. An iteration is one execution of the body of the loop. This is the while loop in Python is a example of a pretest loop. So I already kind of described this concept. So the condition is tested before the loop is entered, and if the condition is initially false, we will actually never execute. We'll have 0 iterations of the loop. We'll never execute any iterations, any of the statements inside the loop. So here's an example of the loop to calculate the sales commission for a salesperson, for multiple salespeople, right? So, notice that basically we're going to be using a Boolean expression to test a string. So as long as the string is y, we will keep executing things. And notice, since this is a pretest loop, this condition needs to be true so that we enter and iterate at least one time. Okay, and then also at the end here is how we change that, right? So we ask the user at the end of the loop if they want to calculate another commission, right? As long as they hit enter y, this will be true, and we will calculate for another salesperson. If they hit anything other than y, this will be false, and then when we jump back up here and test this, it'll jump after and execute the code after the while loop there. All right, so we can run this, call commission. So let's say we had $20,000 in sales at a commission rate of 5%, 0.05 here. So they're earning $1,000 commission, 5% commission rate there. So if we enter yes, when it comes back up here, keep going is y. So that's true. So we'll get another salesperson earning $50,000 at a higher commission, let's say 6%. If we enter anything other than y, what happens is it comes back up here, but when that's false, we will start executing the statements after the while loop block here. So a common bug that programmers make when doing condition control loops is not having, the correct logic to cause that condition to become false at some point, right? So in all but rare cases, loops have to contain within themselves a way to terminate. So a way for that condition that's being tested to become false. So something inside the while loop needs to be changing whatever is being tested so that condition goes from true to false at some point. Okay? So loops that don't correctly do that are known as infinite loops. So a loop that has no way of ever having the condition become false would actually go on forever, right? So, and if that ever happens to you, normally what you want to do is Control C should be defined for most terminals. This will send an interrupt signal to your program so you can interrupt get out of the infinite loop and fix it so that it actually has a correct stopping condition. So here's the example from the textbook about an infinite loop. So the only thing that's different between this and the previous version is we don't add, there's nothing in here asking if the user wants to continue or not, right? So if I ran this, keep going never gets changed, so it's always true that keep going is Y, so it would just forever keep asking you until you hit Control C. Okay. Here's another even simpler example, right? So we just set a Boolean variable called condition, we set it to true, and we have a condition controlled loop, and we're just printing dots here, right? So if we run that, this is an infinite loop, right? So if I don't do anything, it's just going to continue printing dots forever. So this is more annoying than the previous example of an infinite loop. So you really need to know that you hit the Control C in order to send an interrupt in order to get out of that, so I can go and fix my program that has a bug, this infinite loop bug in it. So the other type of loop structure that you'll need are count controlled loops. So in Python, you should be using a for loop, usually to do a count controlled loop. So these iterate a specific number of times. That's what we mean by count control. So in this case, in the syntax that's being shown here, what you give the for loop is a sequence of data items. Okay, so we're going to talk more about sequences. This is really what in Python is known as a list. So it's just a sequence of values in a list here. So the for loop has a sequence of values. We want to iterate over it some number of times over each value in the sequence. So the other thing in the for loop is there's this target variable. So what happens the first time in the loop, basically we're assigning value 1 into variable. And then, and then it does all these statements where value 1 has been assigned to variable. And then we assign value 2 to variable, okay? So so this is showing that. So here we have a sequence of integers, 1, 2, 3, 4, 5. So the first time in the loop, this is like we're doing num equals 1. So num will actually be assigned, the target variable has a value of 1 in it the first time in the loop. So after it prints 1, it will go up and it will do the next value. So it will assign 2 to num, and we'll end up printing 2, and so on. So the result of that, if we have a simple loop like that where we're iterating over this sequence, 1, 2, 3, 4, 5, is we just get the numbers 1, 2, 3, 4, 5, right? So make certain you understand that if that's not clicking, right? So this loop runs for a count of 5 because there's 5 items in the sequence. The first time in the sequence, the variable, the target variable will be assigned 1, so that's why we get 1 displayed here. And then the second time in the loop it'll be 2, so on and so on. To the fifth time in the loop it'll be assigned 5, and then after that we've gone through the sequence 5 times in this count control loop, and we're done. We'll execute the statements after the for loop, right? So you can have. Anytime you're iterating over a sequence, it'll do all the items. So even though we're going to do 5 times, the items in the list, don't have to be 1, 2, 3, 4, 5, right? So if we do this one, we will get the items 1, 3, 5, 7, 9. The items don't even have to be integers or anything. So in the basic way of a for loop in Python for a count controlled for loop is to iterate over all the items. They can be much more complex even than integers, floats, or strings. Again, we'll see a lot more of this in the class here. But in this case, the target variable is going to have a string for each iteration of the loop. Wink and blink and a nod for the 3 times that it will go through in this count control loop. Okay. So sometimes you need to explicitly iterate over where the target variable is an actual integer. Okay, so in many programming languages, this would probably be called like an index-controlled loop. It's a closely related idea. They're both examples of count-controlled loops, but in this case, the number in the target variable, we want it to be like an integer value, 0, 1, 2, 3, 4, 5. So that's really what the range function is for in Python. This returns you can think of this as returning a sequence. So if you say ask for range 10, it will return the sequence 0, 1, 2, 3. It always starts at 0 and goes up to, but doesn't include the last value. Okay, if you only give it a single value in the range. If you give it two values, that is considered the beginning and the ending of the range. So from 5 to 10, we'll give a sequence 5 up to, but not including 10. So it always includes the first one in the sequence, or it defaults to 0 if you don't specify the start. It goes up to, but doesn't include the last one in this integer sequence. And you can actually also give a third parameter, which gives the step size, is what it's normally called. Right. So if I want to go to 2 to 10 in steps of 2, I could specify 2 here for the step size. So count up 2, 4, 6, 8. And again, notice it doesn't do 10 because it goes up to, but doesn't include 10. And you can actually use this as a negative step, so you can actually count down from like 10 to 1 here. And again, though, it won't include the last one. So we go 10 down to, but not including 1 if you're going backwards like this. Okay. So, yeah, just as a just one example of this. So if we do actually, let me something like that, right? So this will use the range statement to go from 1 up to, or from 0 up to, but not including 5 here. So the result should be, so I used the index value in there, and we're just printing out hello world each time. For again, this is a count controlled loop, but we're using the range function to go over our temporary variable for index or integer values 0, 1, 2, 3, and 4. Okay, just a little bit more about the that target variable. I think we covered this, but it's often useful. I mean, that variable, unless it's just a pure index value, but often we need to use that target variable to do something with, right? So, for example, so this code from the textbook, it's actually calculating the square, not the square root. In this example, but we could have changed that to do the square root here. But again, make certain that what would you predict for the output to be here? So remember, we're giving it the beginning and the end, so it goes from 1 up to, but that doesn't include 11. So it's actually just going to give the numbers 1 through 10. We're using the target variable inside of here so that we're displaying the number and the square of the number. If we run this code here, so the result should be that we get each number and we get the square of each number displayed as this loop executes 10 times, basically, from values 1 up to 10. All right, so to summarize what we covered in this video, so repetition structures allow you to write code that performs a block of statements multiple times, okay? So, and this is an important principle. You want to avoid repeating yourself in code, and one of the most basic ways you would do that is to write a loop where appropriate to repeat a block of statements as needed instead of copy pasting those multiple times. Right? So don't repeat yourself as many reasons why you want to practice it. Avoid code duplication, and basically repetition structures are used to iterate over items in a list or an array. Right? And there's two basic types of loops. Condition-controlled loops and count-controlled loops. In Python, you should be using a while loop whenever you're doing a loop that should keep going as long as some condition is true, and stops once that condition becomes false. That's the condition-controlled loop. And you should be using the for syntax, the for loop, whenever whenever you want to do a count controlled loop. Okay, so count, normally what we mean by count controlled loop here for a for loop in Python is we're going to do it some exact number of times, and usually what that means is we have some sequence of values that has an exact number of values in the sequence. So if the sequence has 5 items in it, we want our count controlled loop to execute 5 times, 1 time for each item in the sequence. Okay. And you'll probably be using range a lot, so sometimes you need to explicitly construct the sequence of integers that you want to iterate over, and range allows you to do that, and you can use the begin and end and the step size to get some kind of complex sorts of things. So I think in the assignment you're doing for this unit, you'll need to use range creatively to do a couple of things. Okay, so that's it for this video. I hope, as usual, that these are useful for you. Keep asking us questions if you have them, and I hope to see you in class.